Okay. So it says an instruction is stored at location 200 with an address field at location 201. The address field has a value 500, right? A processor register R1 contains 400. Evaluate the effective addressing if XR value is 100. So let's take our time. We have an instruction, right? Now, you remember that in the volume architecture, we store the instructions in like maybe I store we will location one we'll store the next one location two. That's the volume architecture. So instruction and data are all stored in memory at the same time. But here's the case where we realize that it says the instruction is stored at location 200 and the address field is at location 201. What it means is that if maybe the instruction is maybe add 5, right? The add instruction, it is stored at location 200 and the 5 operand, it is stored at location 201. That's what it means, right? Now, it says that the address field contains the value 500. So what it means is that here is not 5, here is actually 500. Uh, then the processor register R1 contains 400. It means that there is another register. So this one we are referring to memory, but there is another register. There's a register in the processor which contains a value 400, right? And it says we have to evaluate the effective address. Evaluate the effective address for different addressing mode, right? If XR means index register is 100, right? So that's what we are going to do. So you say first, assuming we are using direct addressing mode, right? Now, if you are using direct addressing mode, with direct addressing mode, the address we specify, right, we'll just go to memory and fetch it,
Okay.
right? So in direct addressing, if we specify 500, we'll go to memory location 500 and fetch the operand there, and that's what we use, right? Now, it means that our effective address will be the 500,
Sure.
right? The effective address is like at the end of the day, right? What at like what is the memory location where we are going to fetch from? And the memory location we are going to fetch from is 500, right? But the data we'll go and fetch will be what? We'll come and look for 500 at this column. We'll come and look for 500 at this column. And we say, oh, 500 is pointing to 800. So the accumulator on us towards 800. Do you get the difference? Effective address is like at the end of the day, where are we going to fetch our data, right? So at the end of the day, realize that the address field has a value of what? 500. We are using direct addressing mode. Direct addressing mode is that go and look at the address field. The value specified, they go and fetch it in memory. So we'll look at the address field, it's at 500. So it means that the effective address is of 500 because it's direct addressing. Now we'll come and look at in memory, 500, what does it store? 800. That will be what in the calculator, right? And the second one is what? Indirect addressing. Indirect addressing says that we'll go and look at the address field, right? Now the address field is storing 500, right? Now the value stored at the address field is the address of the operand. Do you get it? What it means is that when we come and look at the address field, the address field is at 201 and it's storing 500, right? We'll come and look at 500. What is it storing? 800. It means that 800 is the location of the operand. So we'll come and see, because of indirect addressing, we'll do it twice. 1, 2, 500, 800, then. So we'll come and then we see that, oh, 800 is storing 300. So it means that the effective address, like at the end of the day, what will be fetching the address from? We'll be fetching the address from what? 800. So that's what you see 800, the effective address.
Sure.
But what is the data we fetched? 300. Because 800 is storing 300. Do you get it? Now the next part is immediate addressing mode. Immediate addressing mode is like this. The operand I give you in the address field, that is what I'm using. Like anyone I'm using. So that is correct.
Sure.
Right? Now remember, in this architecture, when we were storing, right, we stored the operand in what location 200. So that means that the effective address is what 200, right? And the value stored at 201, sorry. And the value stored at 201 is what 500. So the accumulator of total 500. That's immediate addressing. So immediate addressing, if I say add 5, I'm not saying go and look at memory location 5. I want the 5 itself, right? But here is the case where the 500 is actually stored at another place, which is called 201. So that will become the what effective address. But the accumulator will now have what 500. That's it. Now the next part is register addressing mode. Now register addressing mode, when we are doing register, we don't go to memory. So we have no effective address. You get it? We have no effective address. But what is stored in the register? 400. Because the question said, it said what register R1 contains 400. So it means anytime the question talks about register, it's talking about R1. So 400. You get it? Yeah. Now, the next one it says register indirect. It means that go to the register, right? The register will point you to the address. And that address it will point you to the content there is the address of the operand, right? So it is like indirect addressing mode. Go to the address, like the address you fetch. So go to the that it's like indirect addressing. So go to the address, right? What is in that address? It is the location of the address of the opera. So you move twice. So it's the same for register indirect. The register indirect will first go to the register, and this is register 400, right? Now we'll come and look for 400. Yeah, yeah. What do you like, Anna? Come and look for register 400, right? Now register 400 specifies 700, right? Yeah, so and that's register indirect, right? That's register indirect. So uh, it means that our location finally will be picking at 400, right? And the data will be what 700. So that's it. Now the next one is register indirect addressing. Just register indirect addressing.
No, no, we are now a relative.
Okay, we are now a relative, sorry.
Relative addressing mode.
Now relative addressing is anytime you hear relative addressing, think about the program counter. Remember that what this we are doing, remember that we have fetched the instruction. So we fetch 201, we fetch 8, fetch 200, we fetch 201. So now the program counter is now pointing to what? 202 here. We don't know what is here. The question did not show it. The program counter is now referring to 202. Because the program counter is referring to 202, you now put 202 down first.
Okay.
Now relative addressing means that you have to add the content of what is in address field to the program counter. The content of what is in address field is 500. The program counter is 202. So 500 plus 202 will give you what? 702. Right? That is the address, the effective address you are going to use. So you see that 702 is the effective address. What is stored at 702? 325. And that's what you see. You get it. So with program relative address, base register address, those ones you have to add before you get the effective address. You have to follow the effective address to get the operand. Then the next part is index register, the index addressing mode, right? So index addressing mode is kind of the same as the relative addressing mode, but this time it's not relative to the program count. It's relative to the what index register, right? The index register is storing 100, right? But the operand we are storing in our address field is what 500. So 100 plus 500 is 600. So go and check at 600 to get our final operand, which is what 5/4, right? Now the next one is auto increment register. Auto increment, right? Auto increment is like we are going to use the index register, right? We are going to use the index register, but after we have used the auto increment, okay, so register addressing. Let me see. Okay, yeah, auto increment, you are going to use the register, right? But after you fill the register, the content of the register will increase, right? So since you are going to use the register, you don't put anything in, right? But after we use the register, the content will increase. Like after we have accesses, so they mean that the accumulator will now store. If the register was storing 400, so it will come 401. Now, auto increment, we are using register indirect addressing, right? And remember that the register is now storing 401, right? So we'll follow 401. 401 stores 650. That's what place we need. So that's basically this. And we have type of instructions. So the computer provides an extensive set of instructions to give. These ones are just reading. Yeah, reading. I don't see anything here. So that's it for this.